We'll start the second half, and you know, I was really pleased how well those talks fit together in the earlier part, and I'm hoping that we can pick up some of those themes as we go through the second session. So the first talk in the second session will give us some insight into communicating messages for a hazard we haven't heard much about, which is the hazard of weather and health. And I'll invite Dr. Andrew Bones, the head of the Extreme Events section of Public Health England, to give us a talk on that.
Hello. Well, thank you so much for inviting me to be here today. It's been really fascinating listening to those earlier talks and to hearing some of the similarities of the challenges of communicating public health messages as well as weather messages. So what I'm going to do now is to spend about the first half of the talk really trying just to set some background around health and weather, because it may not be something that you're so familiar with, and then move on to how we try and communicate both the risks of weather to health, and most importantly the actions that people need to take. And I guess I'm one of your kind of classic end users. I am the person who's trying to understand the weather information and then translate that into what that's going to mean for health. So Public Health England, in case you don't know, is a special executive agency of the Department of Health. So we are civil servants, we're part of the government machinery, but we are operationally independent. We're a big organisation, several thousand, and we cover a whole range of different hazards. I sit in the green bit, the protection from environmental hazards, but I do work with people across the organisation and also across government, because in order to protect people from environmental hazards, I need to get out of my health box occasionally and talk to other sectors. So the point of PHE really is that our mission is to protect and improve the nation's health and to address inequalities, health inequalities. And as I say, we try to work with as many different organisations as possible to that end. So I work, as Andrew said, I'm head of the Extreme Events and Health Protection Group at Public Health England. This is how we define an extreme event. When we first started out back in 2012, we were trying to deal with pretty much any natural hazard you could possibly imagine. And that quickly became difficult to manage with a very small team and limited resource. So we have brought our focus much more down to the weather hazards that are particularly important for the population of England. That's cold weather, heat wave and floods. We're increasingly doing a bit more work around drought, and I would say that those other hazards remain on our radar, if you like. But I think that the approach we're taking is very much that many of the vulnerabilities are the same, whatever the weather hazard is. And also many of the actions that you would take from a health perspective are quite similar. So a lot of the work we're doing around the three main hazards would be translatable in the event of any of these other risks or hazards. So first, a few myths. These are myths I have heard in the last 4 years, or some of the myths I have heard, should I say, in the last 4 years of working in this unit. So first of all, I hear often that, you know, we don't really have extreme weather in England. You know, what are you on about? It's not Africa, it's not Australia, it's not Asia. You know, stop making such a fuss. And I think, you know, my answer to that always is, well, you know, yes, certainly we don't have the extreme hurricanes that we're seeing in the Caribbean at the moment. We don't have extremely high temperatures or extremely cold temperatures. But in fact, everything around health is relative. And it really does depend how you are physiologically acclimatized to your environment, but also how your behaviors, your infrastructure, your cities, your homes are adapted. So you might be quite surprised to hear that health impacts on average start at around a mean daily temperature of around 4 to 8 degrees, depending on the region in the country, in terms of cold. In terms of heat, health impacts start between 20 and 25 degrees as a maximum temperature, daily temperature. So these are not real extremes. These are really quite moderate climatological conditions for England that you would see in a normal summer and a normal winter. Obviously, the risk increases the more extreme it gets, but health impacts start at really, really early temperatures. The other thing I hear a lot is, well, you know, those people who do die, they die of heat stroke and hypothermia, and if you look at the data, there's only a handful of those each year. So, you know, it's not really a big health issue. And the point is that when people die of heat or cold or related to flooding, it's not recorded on the death certificate as this person died of heat, this person died of cold. It's recorded that they had a heart attack, or they had a stroke, or they had pneumonia. So it's quite difficult to extrapolate exactly how much is due to the weather. But you can do that through time series regression analyses, comparing daily mortality, daily morbidity figures with temperature and other environmental variables. So the other thing I hear is, well, okay, but it's only really the old and the frail, and they were going to die anyway, weren't they? And that's not true either. Certainly, we have done some quite clever, again, regression analyses which show that particularly for cold, you're not just bringing deaths forward. You are causing premature death is resulting as a result of cold. And the other thing to remember is that, in terms of sleep disturbance from heat or respiratory infections in children with asthma, there is a big health burden from these conditions, from these weather conditions, and it's not just a problem restricted to a small part of the population. Another one is, well, hey, it's all about outdoors, isn't it? The weather only happens outdoors, it doesn't happen indoors. But we know that between 80 to 90% of our time is spent indoors. We're indoors at the moment. And the people that we would be particularly worried about, who may be more vulnerable because of age or because of illness or because of disability, may well spend even more time indoors. So we have to also bear in mind that it's not just the outdoor conditions, it's also the indoor conditions that are important, and obviously, they're totally related. Then the nanny state complaint that we get, that everyone knows the risks about weather and health, and we all know what to do, so stop telling us what to do. And I can understand that perspective, I really can, but I think again our response would be, whilst most of what we would suggest is common sense, there are particular groups in our population who may find it difficult, either because of disability or because of dementia, for example, or they're socially isolated. And this is why we think it's really important that we do continue to put out those common sense messages and encourage people to think about people in their neighbourhood, family, friends who might be finding it difficult to take common sense actions. And then the other thing I hear is that, well, hey, the weather's the weather, you can't change the weather. There's nothing you can do to change the health risks. And we would argue quite strongly that there's quite a lot of evidence, both in terms of upstream resilience around our housing, our community, social isolation that we can do something about, and also the emergency responses. So I'm going to briefly skip through the health impacts of each of those three hazards, just so that you know the background. So with every hazard, there's a direct health impact because of the exposure on the body, the physiological changes, and then there's indirect health impacts that happen either because of cascading effects or because of people's behaviour in relation to that hazard. So in terms of cold, we know that cold changes your blood pressure, it increases your blood pressure, it makes your blood stickier, and you're more likely to have a heart attack or a stroke in cold conditions. We also know that you're more vulnerable to respiratory infections and worsening of things like chronic obstructive pulmonary disease. It causes bronchoconstriction. We also know that hypothermia, just from cold exposure, is also an issue. But those are the key issues for direct effects. In terms of indirect effects, we know that living in a cold home, for example, has really substantial mental health impacts on adolescents and on working age population. It can also cause social isolation, particularly in the elderly, and reduced activity, which is really important if your blood is getting thicker because you're cold, you're also increasing your risk of a cardiovascular event. Carbon monoxide poisoning increases every winter as people try to keep warm using methods that perhaps aren't recommended, or they've got faulty boilers, and we see burns in people trying to get themselves warm with hot water bottles or with those little iron barred heaters. Respiratory disease is also an issue because we see more infections, not just because of the physiological effects, but because people congregate indoors, which means that things like flu spread more quickly. And we also see health service disruption, for example, if the roads are closed, or there's much more increased demand, and you'll all have heard about winter pressures on the National Health Service. And utilities, broken pipes because of cold weather, or transport disruption, or communications going down, or power going down. In terms of hot temperatures, again, direct and indirect, the key things that people worry about for heat are heat stroke and heat exhaustion, but actually it's far more common for people to have deaths as a result of worsening existing disease, either neurological, respiratory or cardiovascular disease. Indirect effects can be because of poor air quality. We see an increase in injuries in the summer, particularly in children. Foodborne disease spreads much more quickly in hot weather. Harmful algal blooms producing toxins and contaminating mussels, for example, has happened. There's good evidence that there's an increase in crime, and again, these other disruptions. What I should say, which might surprise you, is that there are about 40,000 cold-related deaths in this country a year, and about 2,000 heat-related deaths in this country a year. So they are quite significant problems in terms of numbers of deaths. In terms of health impacts of flooding, again, the direct effects are pretty obvious. Drowning, physical trauma, infections from contaminated water. It's actually the indirect health effects which are far more are more concern to us because they persist. Mental health impacts, particularly from having to deal with the loss of your home, your livelihood, your possessions, and dealing with builders, insurance companies, and how long it takes to get back into your home after flooding. Carbon monoxide poisoning is also sadly an issue in relation to flooding because people bring in fuel-driven generators indoors to help dry out or to replace missing power, not realising the risks there. And I won't go into all of those other points there just in the interest of time. So, who is most at risk? Weather hazards can affect anyone, of course, but there are some groups that are more at risk than others. And again, I don't suspect that list would surprise you particularly in terms of age extremes, people who are unwell or less able to adapt their behaviour, homeless people or tourists or migrants who can't necessarily know or understand the warning systems and systems locally to help them. So we tend to take an approach which is called proportionate universalism. This was coined by Michael Marmot, who is one of the professors who's done a lot of work around the social and economic determinants of health. And it essentially says everybody needs the same information, but some groups need extra in order to help them respond to whatever the health threat is. So my team run the cold weather plan for England and the heatwave plan for England, and we also feed into DEFRA's National Flood Emergency Framework for England, and these are multi-system plans that are designed to reduce the risk from these hazards. And I'm not really going to say anything more about them now in the interests of going on to all the stuff I want to talk about communication. So in terms of communication, you will be aware of the Civil Contingencies Act, and that Category 1 responders are required to warn and inform and advise the public in the event of an emergency. Public Health England is a Category 1 responder, so we have a statutory duty to warn and inform in relation to weather. So what we're trying to achieve, obviously the main aim is that we want to minimise the impact on the health of individuals and communities, and also minimise the impact on health services by trying to keep people as safe and as healthy as possible so that they don't end up in the health services. In order to do that, we need to raise awareness of the risks, but just telling people there's a risk is not enough. We need to tell people what they can do about that, what is an effective action to take. And these are before, during and after an adverse weather event, again, both for the public and for professionals, and in proportion to the risk. And we've already talked a little bit about raising false alarms, being clear where there is a lack of confidence, and also being aware that people have other imperatives and they have the choices and the knowledge to make the best risk decision for themselves. So we can provide them with the information and as much support as possible, but it is ultimately down to people to make the best choices that they can. We need to make information readily accessible and tailored to people's needs, bearing in mind that there are large parts of our community that don't have very high levels of literacy, for example. So whereas we may want quite funky communications, that may not always be accessible to all groups of the population. And there really is an important role in making sure that information is consistent across organisations. We have had incidents where one organisation has been giving slightly different advice to another, and that causes a great deal of confusion in the minds of the public. So in terms of the channels that we use to communicate our messages, we have already touched on warnings. I have images there of the National Severe Weather Warning Service, also the heatwave alerts that we use as part of our heatwave plan. We have a similar system for cold weather plans and flood warnings. I think the advantages of having a formal warning system is that there is evidence that warning people minimises impact, and it's helpful to have standardised, widely disseminated early warning, which is tailored both to the public or to responders as appropriate. But there are clearly a number of questions. Are the warnings understood? We have done some work, particularly with King's College, which suggests that people don't really understand the heat and cold warnings. They find the get ready go approach that we have. So level 2 is it's going to be hot. Level 3 is it is hot. Difficult. They imagine that because of the colour grading, this is a graded system, it's hot, it's getting hotter. Do they prompt effective action? I think that we do certainly have some evidence that people are changing their behaviour as a result of some of the heat and cold messages that we've been putting out there. Are they reaching those that need them? Again, I think that is a question. They are reaching some of the population, but perhaps not those who are most vulnerable, and I think there is more that we can do there. And are they provided at a useful time and space scale? And my feedback from all of our end users is it's the geographical scale, which is far more valued than any sort of longer time lead-ins. There's always a desire to know, is it my hospital, is it my care home that is going to be affected? And are the thresholds at the right level is a whole other conversation that we won't go into now. But understanding when you call it a yellow alert, when you call it an amber, when you call it a red alert is quite challenging. We do have other communication channels. We do have a lot of information that's available on the .gov UK website and also the NHS Choices website. There are advantages in that it is there all year round. I can be assured that it contains the best evidence-based, most robust information we have. We do use various different formats, and we would encourage any other organisation to use that and make it their own, if that's what will get the message to their local populations across better. But we do have some concerns. We're not sure that people can always find the information. We do test all of our materials, but I think that sometimes it could be better presented. We do need to make sure that there is information consistency, as I've mentioned. We have had experiences where the websites that host our materials have taken our material down without telling us, which is, again, another challenge. And again, this big question of, does it actually change anything in the end? We use traditional media a lot. I spend a fair amount of time talking to journalists, both print, radio, TV. We like doing that very much. Firstly, because we know that there's great reach and possible impact from doing that, and we know that the weather is always a story, and it's important for us to get the right messages into that discourse. But we do have some challenges occasionally. We have information that's sometimes taken out of context or not presented quite right. So this one was one that I got burnt with, just heat one room, crazy, shocking scandal of government advice. This was where we were trying to take into account other people's imperatives and their constraints on action, and recognizing that some people can't afford to heat their entire home, either because they're in fuel poverty, for example, or for one reason or another. So we were saying, the actual line in the advice says, if you can't heat your whole house, then at least heat the room that you spend most time in. But that obviously got rather changed by that headline and caused me no end of trouble. The other things that we do enjoy and think is very valuable is working with the local radio services, because again, we think that a lot of the people who really will be most vulnerable, particularly older disabled people, are more likely to be listening to local radio. And we have done a series of adverts, so those MP3s that I can't play for you, unfortunately, are about cleaning up and drying off following flooding, and were very well received, and everybody who heard them remembered them because they sounded like a 1970s nuclear war warning, but it did get the message across. Okay, and again, does this actually change behaviour in the end? A question that is actually quite hard to answer. We use social media as well. We have old blog streams, we have created animations, and we tweet. And again, it's the same questions. And the other thing about social media that we worry about is, does the desire to get good images put people at risk? Which is something we need to be aware of. And also, does the information that is shared through social media actually reach those people who are most at risk? And lastly, marketing campaigns. We have a social marketing department in Public Health England. I don't know if you're aware of social marketing, but it's essentially using advertisers' commercial marketing techniques to create formal campaigns around particular issues. And it is extremely costly and resource intensive, but it does incredibly thorough testing of different audiences, different segments of the population. It focuses on behaviour change techniques that are looking at trying to understand the constraints and the complexity and what it is that would actually change behaviour. And they have specialist design support. We've had some success in working with our social marketing colleagues. We put a leaflet, the top tips for keeping warm and well, into Department for Work and Pension benefit letters, which went to people who are aged over 65 and on pension credit, so about 1.8 million people. And you may have seen the Stay Well This Winter campaign that encourages people to go and have flu vaccination, but also to use their pharmacist and to keep warm, which uses the NHS blue colours, which uses NHS staff, the Lewisham Choir, for example, to try to get messages across that way too. And other examples that Public Health England have done, the One You campaign, the Walking for 10 minutes every day, Change for Life, that is all from that department. I have to say that given the large numbers of health problems that our population experiences, weather is probably a smaller part of what is important in the bigger scheme of things, but we do have some success there in working with them. So in conclusion, PHE's role is to protect and improve health and reduce inequalities, working with others. It's clear that the weather has a range of direct and indirect health impacts. It is our statutory duty to warn and inform the public in event of an emergency. We aim to provide evidence-based information that's accessible to everybody and that actually promotes health protective behaviours. And we use a range of challenges and work with a large range of partners to continue to improve our communication. So thank you very much.
Angie, I think it's time to just look at questions.
Thanks, Angie. I'm going to ask you about Heath. Because I think that is one area where definitely the cultural kind of behaviour change in this climate, that people are not aware of the risk and they're not aware of what they they should do. They open the windows in the middle of the day. They don't realise the value of external shading. And how do we go about that?
Yeah, thank you for that question, Rachel. You know that this is a subject that's quite close to my heart. I think we are moving people gradually to understand that heat is a significant risk, and with climate change is going to be an increasing risk. We're doing a second survey this summer, having done a survey 4 years ago of people's understanding of heat risk and their behaviours, but we don't have the results yet of that. But I'm hoping that we will actually be able to demonstrate a shift. I think as temperatures continue to get hotter, we will find that people will either start trying to change their behaviour and introduce passive cooling measures to buildings, or they will start putting in air conditioning. And obviously air conditioning has a range of negative consequences, including pumping out heat into the environment, issues to do with energy security, issues to do with equality, and obviously carbon emissions. So I think things will change. I think they have to change.
Thank you very much. I read in the Evening Standard last week that the BBC, ITV and local radio stations in London were looking to add air quality information into the forecast. This clearly has a close impact with health and well-being of individuals. How can forecasters best position this information into the forecast to best support the general public?
Okay, well, I should say, first of all, that air quality is not my area, although I do work in the same department as those who do, and we have lots of contacts because there is clearly an interrelationship between temperature, air quality, health. I think that broadcast forecasters could play a really important role in disseminating messages. At the moment, the National Severe Weather Warning Service, for example, doesn't include things like heat and cold and air quality, but they are able to disseminate those messages from the National Severe Weather Warning Service through that route. And so that is something that I think I would be very keen to explore further.
Thank you very much.
Okay, I think we probably have to move on, but hopefully you'll be able to grab Angie afterwards and ask her some questions. So thank you, Angie. Okay, so the next talk is from Marie Rutledge from the University of Essex, and I hope this will pick up another of the themes that we talked about earlier, which was thinking about language and how language affects our communication.
Good afternoon, everybody. Can you all hear me? Yay, cool. Thank you for being here, and thank you for having me. Thank you, Andrew, for inviting me. I'm Marie Juanchic. I'm a psychologist from the University of Essex. The work I will present today was conducted in collaboration with Dr. Shepard from the University of Reading and Dr. Sirota, also from the University of Essex. My goal today is to convince you that we can better leverage the language of uncertainty to improve the way we communicate uncertainty and risk. So I will show you how we can use different lexicons to help people make more cautious decisions, for example. This is an interesting display, I think, because it shows you the number of people who died for causes related to climate change in red, and the number of people who died because of terrorism in black. It's the small dots at the top that we can hardly see because they are so few. Basically, the idea is that climate change has really negative consequences now. That was from 2000. Now it's even worse. But although climate change causes a much more negative impact, actually it doesn't leverage so much policy support and doesn't worry people as much as terrorism, for example. And we see that our politics worry much more about terrorism than about climate change. So why is this? One of the reasons, and there are many, but one of the reasons, and the one I propose to tackle, is that it's because of the way we talk about climate change. Climate change is uncertain. And we asked just before about the terminology we use to talk about natural disasters or climate change, and it's always about uncertainty, and I think that has to change. This is the lexicon that is recommended by the IPCC to describe climate change. The IPCC is the Intergovernmental Panel on Climate Change. So for example, as you see, they have a specific vocabulary that people should use when they talk about climatic events, like if it's 10% likely, you should say it's very unlikely. If it's 20 or 30% likely, you should say it's unlikely. So you maybe start to see the problem with these guidelines is that it features a lot of negations, exceptionally unlikely, very unlikely, unlikely, about as likely as not. And this is a problem because, well, there are different reasons. But one of them is that negations are harder to process. People find them harder to process than as statements that don't feature negations. Also, when we see a sentence that features something like unlikely, it triggers automatically in mind reasons why the event may not happen. So it fits better negative evidence or evidence against the outcome occurrence. Also, when we think about something that is unlikely, it triggers in mind the idea that the outcome is less and less likely, or that there is a disagreement. It was more likely before, but someone says now it's unlikely. And there are studies also that show that this kind of vocabulary that features some negation actually trigger lower responsiveness, or it doesn't encourage action. So what we propose is to use a more positive lexicon to talk about climate change. And here you can see the alternative one that we propose to use that is a more positive version of the original IPCC one, and that we think communicate the likelihood ranges that are still written on the right. So we propose this new lexicon, but now we have to prove that it's actually as good or better than the previous one. And I will show you 6 key quality checks in 4 experiments. First, I will show you that the new, or I will test that the new lexicon fits better with positive evidence, that it conveys a similar average probability ranges, that it matches the expected probability ranges as well. Importantly, that this new lexicon encourages more cautious decisions, that it's judged more useful by users, and that it elicits more trust. We talked before about the crying wolf effect. We'll see a bit about this after. So in the first experiment, we tested whether the new vocabulary, the new lexicon, fitted better positive evidence. And we asked people, for example, we gave them sentences like, it's very unlikely that a storm will hit Houston because, and we provided a positive reason, because some models show it can happen. And people judged how appropriate this sentence was. And in contrast, we gave the same sentence, but with the positive equivalent, the positive lexicon, again with the positive evidence. And here you can see on the left axis how well the different lexicon fitted with positive evidence, a measure that we call directionality. And in blue, you can see the alternative lexicon, and in red, the original one. And so what we can see is that people believe that the new alternative lexicon fitted better with positive evidence. So if you say it's very unlikely, people think of negative evidence. But if you say the equivalent in more positive terms, people will think that positive evidence much better. So the next thing we wanted to test was whether the 2 lexicons actually communicated similar levels of probabilities, because that's the whole point of having probability communication guidelines, right? So we ran 3 experiments to test this. One in which the terms, the probability terms, were presented in isolation without an outcome. So this is experiment 2. And 2 experiments in which the lexicon was presented within a climate change context. It qualified 2 different outcomes. So we had, in the first experiment, 4 probability ranges that were compared, and again 4 in the subsequent 2 experiments with the 2 lexicons. We did these 3 experiments on different samples. Experiment 2 and 3 were done in the UK. One was done in the lab, one was done online, and experiment 4 was done online with an American sample. So this is the result of experiment 2, and what you see here again, in red you have the IPCC original wording, the negative one, and in blue the more positive one. And what you see on the x-axis is the level of probability that are communicated. So basically what the analysis showed is that there are no differences in the probability conveyed. So the alternative lexicon conveyed a slightly lower probability than the IPCC original one, but it's not statistically different. In this graph, I plotted the number of probability estimates that fitted the guidelines. So at the beginning, I showed you that you have a specific vocabulary to use, but it should also match a specific probability range. So for example, unlikely should be used for probabilities between 0 and 33%. And so here, I counted the number of people who actually gave an estimate that matched the expected range. And what you see is that people didn't do very, very well with extremely low and very low probabilities. But what you can also see, and what matters most to me, is that the alternative lexicon that we propose to use did as well, if not better, than the IPCC original lexicon. So you have similar level of consistency with the existing guidelines. These are the probability estimates for experiments 3 and 4, which were conducted in a climate change context. So people were given sentences like, it's very unlikely that the temperature will rise by more than 5 degrees Celsius, for example. Don't ask me whether this is the case or not, but they were given sentences like this, and they were asked to translate this into an actual numerical probability. And the way they did it, what we can see is, again, that there are no differences in the way they interpreted the existing IPCC vocabulary and the new alternative one. This is, again, the consistency with the IPCC guidelines, and what you see in red is the existing original lexicon of the IPCC, and in blue, the new one. And what you see is that it's either very similar, the new lexicon is either very similar or even better than the previous one. So using a positive wording to describe climate change doesn't impede probability communication. We have 3 experiments now that show that it does as well of a job as the existing one. So the next step, so we show that, okay, we convey the same probability, but now can we do better in terms of decision making? Can we do better in terms of trust? So that's what we aim to do with the decision-making study. We did the study in a landslide forecast context. So it was a sort of game in which people were given a forecast, and they had to decide whether they should evacuate or not an area. They were paid a flight fee to take part, and they were also paid based on performance to help them engage more with the game. So they made 48 decisions based on the 2 lexicons. There were 4 probability ranges and 6 trials per probability range and per term. In the same experiment, at the end of the decision-making process, we asked people, did you find those forecasts useful? If you made a mistake, would you blame the person, the forecaster, or would you trust them next time? And here's a way to depict the landslide experiment. So people are given a forecast. then they make a decision, they decide to evacuate, for example, and maybe a landslide doesn't occur, and that's too bad because they evacuated, so they lose some points. Or they did evacuate, and then it's great. They made a good decision, and they earned some points, and they earned some money with it. Or they decide not to evacuate, and there was a landslide, so it's all right, everything is fine. Or they decide not to evacuate, but there is a landslide, and that's really bad because there are many casualties. Here, I have plotted the number of evacuations per round. So you remember, they make 6 rounds of decisions that are plotted here on the x-axis. On the y-axis, you see the number of evacuation decisions, and each plot shows you a probability magnitude. So this is what happened for an extremely low probability, very low, low, and medium. And what you can see is that consistently with the blue bars, people evacuated more. They were more cautious based on the alternative lexicon. So they were more likely to decide to evacuate at all the probability levels and throughout the rounds. Here you can see the performance of participants. As you have seen, they earned some points for each decision they made. And so this, here I have plotted the actual performance in terms of points and in terms of money they earned. In the first plot, you see an almost flat line because the probability was set as 1%. So the landslide occurred only in 1% of the time. And so it occurred so very little that it didn't really change people's performance. But for the very low, low, and more even so for medium probabilities, then you see an increase in differences. And in fact, as there are no differences for extremely low and very low probabilities, but for low and medium probabilities, you can see that the alternative lexicon helped people perform better and earn more points and more money. This is the utility perception of the traditional IPCC forecast and the new ones. And this is the only disappointing finding. People actually found the original IPCC lexicon more useful. Because it's true, they made better decisions with it if we count the number of wrongful evacuation. So their actual feeling was that the IPCC original wording was more useful, especially for extremely low and very low probabilities, less so for low and medium ones. This is blame on the left and trust on the right. And so this was the question was, imagine someone made a mistake after the forecast was given. Now, how blameworthy would be the person, and how much would you trust the person next time? So what you can see is that people would blame more the person if the person uses the original IPCC vocabulary than compared to the alternative scale, and that they would trust more the forecaster if they use a positive wording compared to a negative one. So what I have shown with these 4 experiments is that the new, more positive vocabulary to communicate about risk and uncertainty fits better with positive evidence. It conveys a similar average probability. It matches as often the expected probability ranges. It encourages more cautious decision over time. It's not judged more useful, actually it's judged less useful, but it elicits more trust and less blame. So the conclusion here is that yes, we can leverage the properties of language to improve decision-making quality and trust. And this form of framing is only one of the ways we can use language to do so. There are many other subtleties about language that we can leverage to help people make different decisions. I wanted to say also that using a more positive vocabulary is not a good option in every situation. So for example, if you are working with the police, I would say you should do the opposite. your frame of mind should be more like being cautious. Is the opposite, is thinking maybe the person is not guilty. So using a positive lexicon is really important in cases like climate change, where not taking action has more damning consequences than actually taking action that was not really necessary. And so for the next steps for this research, we may try to see whether the new lexicon creates more worry and more policy support to reduce climate change. And we aim to develop more applied projects in collaboration with the professionals and practitioners, because we know that the kind of scenarios we are using are very sort of remote for people. So we are keen to develop more realistic scenarios to test in our future research. Thank you very much.